A plan to create an impossibly long bridge across the Californian Golden Gate Strait was developed in the 1920s, decades before the technology and innovations that have transformed the building industry today. Today, that structure remains one of the world's most famous landmarks, but to truly appreciate the magnitude of this achievement, you need to understand the bridge's story. A mile-wide passageway connecting San Francisco Bay and the Pacific Ocean is known as the Golden Gate Strait. Through this channel, several creeks and mountainsides in Northern California pour into San Francisco Bay and out to the ocean, creating swiftly moving, hazardous water. Prior to the bridge's construction in the 1920s, a ferry was the only option for channel crossings that did not require a lengthy trip around the bay. By 1929, there were over 2.5 million car journeys conducted across the water annually due to the rise of cars and the expansion of San Francisco during the boom years. Growing requests for a bridge effort over the gap were prompted by the congestion. Many believed that such a feat was impossible. Many believed that the channel's width combined with a depth of nearly 372 feet, or 113 meters, and tough conditions were too much to overcome. For help determining if such a plan could be implemented, the city turned to famous bridge engineer Joseph Strauss. Although Strauss had a long history of building bridges, he was notoriously difficult to work with and had a bad reputation for producing unattractive designs. His first proposal was widely disliked, and the city's authorities insisted that he could only proceed if he accepted design input from others. This advice, which came from Charles Alton Ellis, Irving Morrow, and Leon Moisseiff, helped to shape the bridge into what it is today. Despite widespread support, it was difficult to have the bridge approved. A holding corporation created to build and manage the bridge, the Golden Gate Bridge District, encountered opposition on several levels. The Southern Pacific Railway Company, which ran the incredibly lucrative ferry service, was their first opponent. In an effort to stop the bridge from opening, the operator filed over 2,300 lawsuits. The U.S. Department of War, as it was known at the time, was the next obstacle they faced. They anticipated that enemy aircraft would attack the bridge, causing it to collapse into the strait and enclose Navy ships in the bay. They also expressed worries about ships running into the bridge in bad weather or in the famed fog of San Francisco. To make the bridge more noticeable, the Department of War even lobbied for it to be painted black with yellow stripes. After some resistance, the project to build the bridge moved forward. But as soon as that achievement was made, the Great Depression and financial meltdown began. The bridge's future appeared to be highly dubious as government funding dried up. The city's leaders took matters into their own hands since they were determined to enhance their economy with all the advantages the bridge might provide. They presented a bond measure secured against the homes of their constituents in San Francisco and the counties to the north of the bay in order to raise money. Despite considerable doubts regarding the bridge's viability, this choice was put to a referendum in a rare move, and Californians opted to move forward with the project. Only in 1971 were the bridge's $35 million USD price tag and related financial charges fully repaid. Construction work began after this historic vote and a $5 million credit line from the Bank of America's founder. Despite all the effort that had been put in up until this time, the most difficult days were still to come. The bridge's towers were built in January 1933, marking the start of construction. These buildings each weigh 22,000 tons and are 746 feet tall, or around 227 meters above the bay's waters. They support the entire bridge's weight. The North Tower was built on the Marin County riverbank as the initial stage, along with the footings. The South Tower's construction was much more difficult due to the strait's rough water. First, the team constructed a makeshift pier that extended 335 meters, about 1,100 feet, into the water. During construction, this pier was demolished twice, once by a storm and once by a steamer ship sailing through fog. Pilot bombs were dropped down shafts at the end of the pier to dislodge the seabed rock. Stunned fish floated to the surface as seagulls flocked around this operation. Before the initial underwater concrete pour, the area was dredged to dislodge the bedrock. The remaining concrete was then dry poured once the area had been drained out. On both banks, the concrete anchorages for the suspension cables were simultaneously cast. An on-site mixing facility was set up due to the volume of concrete being poured across the bridge site. The steel south tower was built after the southern footing was put in place. The procedure of suspending cables from the bridge was the next phase, and it started in the summer of 1935. The cables in use are made up of several individual wires. To be exact, 27,572 wires totaling 80,000 miles in length, or enough to circle the globe 3 times. The initial wires were pulled across the bay by a Coast Guard vessel after the shipping lanes had been blocked, and they were then raised by a crane into the 150-ton curved cable cradles atop each tower. Then a working platform was slid across. Once this was completed successfully, the laborious operation of bundling and draping wire strands back and forth across the bridge started. Workers at the top of towers toiled for months in gusts of 45 miles per hour, 746 feet above the ground. Despite the adverse environment, productivity was high, and a team spun 1,000 miles of wire across the strait in one record-breaking shift. Each wire was tightened at the other end as it passed, finally becoming the bridge's 2 main cables, each measuring 3 feet in diameter. In order to weave, condense, and join the wires before painting them to form a waterproof cover, workers first suspended wooden pallets beneath the cables to create a catwalk. Smaller vertical cables were lowered towards the water once the main cables were set up. Steel trusses were then attached to them, creating the deck for the concrete roadway to be poured on. Many construction workers lost their balance while working on the bridge. Most times, a fall from the road deck into the lake was lethal because the impact speeds could reach 75 miles per hour. Many construction workers who fell were prevented from hitting the ocean and joined what was known as the Halfway to Hell Club, thanks to a then innovative safety net. In February 1937, a tragedy occurred when a paving machine toppled into the net, taking several workers with it. 10 people were killed when the net collapsed under the weight of the machine. The debate over what colors to paint the bridge increased as construction continued. It was the bridge's orange steel primer that struck a chord with the public and suited the Department of War's requirements for visibility. Actually, this color is referred to as International Orange. It is a striking shade that is also used on American football teams and NASA astronauts. The bridge was finished 4 years after construction work began and had 600,000 steel rivets. Cars arrived 24 hours after the pedestrian walkover day on May 27, 1937, when it officially opened. For the bridge's 50th anniversary in 1987, the walkover day was repeated with traffic suspended. However, there was significant congestion, and the bridge shifted by 10 feet, flattening out under the pressure of the crowds. This extremely dangerous incident has led officials to commemorate anniversaries in different ways ever since. Since it completed, the bridge has had tremendous cultural and economic success. The Golden Gate has been used by more than 2 billion vehicles, and the city of San Francisco has come to be associated with it as an American icon. Security has intensified as a result of this position, especially in the years after 9/11. Additionally, measures have been taken to better safeguard the bridge against seismic activity, particularly in light of advancements in science and technology since the 1930s. Due to its location between the San Andreas and Hayward fault lines, the bridge is vulnerable to earthquakes of significant size. The towers supporting the approach ramps have been fully overhauled, and energy dissipation devices have been subtly installed. A staff of 110 full-time employees is responsible for the continuing maintenance of the bridge and handles every element. The bridge is similar to an offshore oil platform in terms of maintenance. It has to deal with oceanic conditions and the barrage of elements that go along with them. Specific portions are repainted based on corrosion monitoring, and a steel fabrication shop on site creates replacement components. There have been larger-scale renovations, including the total replacement of the suspension ropes in the 1970s and the installation of a new, lighter steel road deck in the 1980s. The bridge, which is now in its 80s, remains one of the single most important elements of U.S. road infrastructure. A key piece of cultural and construction heritage and an iconic symbol of what human engineers are truly capable of.